My name is Sophia Schenk, and I am a sophomore at Alter High School. The title of my project is The Effectiveness of Different Soundproof Materials on the Detection of Sound. I chose this project because I work with sound a lot as a singer and am working on building my own sound studio in my basement, which is why I chose to test the question, which form of soundproofing out of ceramic microfiber insulation, polyethylene foam, professional acoustic sound panels, and plain plywood would be the most effective. In order to understand this experiment, I first had to research what sound is. Sound is created when sound energy creates a vibrational object that sends a pressurized wave of energy through the surrounding medium, usually air. The pressurized wave causes the air particles to vibrate as well, thus transferring the energy. I also researched a decibel system, which is how I measured volume in this experiment. The decibel system defines the softest audible sound as 6 decibels, the sound causing instant destruction of the eardrum at 160 decibels. Next, I researched what happens when a sound wave reaches a solid mass. While there are many possibilities, the most common two are absorption and reflection. Sound absorption occurs when a sound wave is absorbed into a new material, eliminating reverberations. From what I've learned, sound absorption works like a sponge soaking up water. Sound reflection is when a sound wave is traveling through the air and strikes a different medium, then bounces back in some other direction. The main purpose of soundproofing is sound absorption. The more porous and soft the soundproofing is, the easier and more effectively the sound wave is absorbed. Finally, I researched how I would measure the sound in my experiment. A decibel meter is a machine that measures sound pressure to evaluate sound level/noise. It uses a microphone to capture the sound, which is then measured within the machine, and then displays the results. With all that being said, the hypothesis formed for this experiment was if different soundproofing materials such as plywood, ceramic microfiber insulation, polyethylene foam, and professional acoustic sound panels are used, ceramic microfiber will be the most effective because it is made of alumina and silica in an approximate 50-50 mixture, creating a porous wool-like material that will absorb the sound. The methods I followed for this experiment was first I built 4 plywood boxes with a detached lid. You can see 2 of the boxes I built on the screen in front of you. Then I placed each of the soundproofing materials into their own box, leaving one with just the plain plywood. Then I placed a buzzer at 900 Hz inside each box and covered it with a lid with the corresponding soundproofing material. Then I measured the outcoming sound 30 times for each box, letting the buzzer play for 10 seconds before measuring. Once I finished all the experiments, I compiled all the data into a table and compared the data. The independent variable was the soundproofing material used in the box, while the dependent variable was the volume of the outcoming sound. Some of the control variables included the size of the boxes, which was 1 foot by 1 foot, the buzzer was played at 900 Hz, and the decibel meter was placed 1 foot away from the box. If you look at the screen, you can see a picture of what the testing area looked like. You can also now see on the screen a table and graph of the averages of my results. This shows that ceramic microfiber was the most effective, averaging only 35.2 decibels, followed by the acoustic panels that averaged 45 decibels. Next was the polyethylene foam, which averaged 51.4 decibels. Finally, the plain plywood box averaged 55.1 decibels. The results proved my hypothesis correct, which makes sense because ceramic microfiber was the most porous material and soft material, so the sound waves were able to be absorbed instead of the wave reflecting like it did with the plain plywood. This experiment has demonstrated that, through the process of sound absorption, ceramic microfiber insulation is proven to be the most effective soundproofing material out of the 4 tested. The flaw that took place was the interference of ambient noise. Ambient noise, also known as background noise, is any noise present in each environment aside from the primary sound an individual is measuring. Some contributors to the ambient noise could have been passing cars, creaking floorboards, or buzzing appliances. If you take a look at the table on the screen, you can see how the results deviated due to ambient noise, but you can also see that in the averages graph and on the table on the screen, that even with the minor deviations, the results stayed consistent, so I don't think it interfered with my results. Through this experiment, I have learned the most common form of soundproofing does not make it the best, as shown with the acoustic foam panels. I also learned that ambient noise is all around us, even though we learn to ignore it. A future question I have is which form of soundproofing is the most eco-friendly in terms of pollution and biodegradability, and which material lasts the longest. Thank you.